So here I'm asked to write 4 over 50 as a percentage. So initially here I'm working with a fraction and I'm wanting to convert it to a percentage. Now when I have a fraction, in order to convert it to a percentage, I can take it to a decimal and then to a percentage. And this is an easy method to go through. And to take it from a fraction to a decimal, you simply do the division. So I'm going to do 4 divided by 50 and get this in decimal form. And then to get from a decimal to a percentage, we just multiply by 100 and that takes us to a percentage. So if I do 4 divided by 50, which is basically what this fraction is showing us, it is 4 over 50. That's going to get me 0.08. And now if I take 0.08 and multiply this by 100 to get it as a percentage, that gives me an answer of 8%, which is the correct final answer here. So in this question, I'm asked to write 1.59 correct to 1 decimal place. Now I can see that 1.59, after the decimal place there are 2 integers, so this number is to 2 decimal places, and I'm going to want to take this number and round it to 1 decimal place. Now when I'm rounding numbers, I always look to the decimal place after the number of decimal places that I want to round it to. So initially here I'm going to be looking at the second decimal place, which is 9. And 9 is greater than 5, and if this integer is greater than 5 or greater, we're going to round up. We're going to round the previous integer, so the first decimal place is going to be rounded up. So we're going to round up this 5 and it's going to take us to 6, and then that's going to be rounded to 1 decimal place, so it's going to go to 1.6 is going to be 1.59 correct to 1 decimal place. However, if the second decimal place were less than 5, so 0, 1, 2, 3 or 4, we would round down and then it would round to 1.5. So here I'm asked to work out the value of 3, which is raised to the power of 5. So raising a number to a power basically means that you're going to multiply it by itself this many times. So for example, if we had 3 squared would multiply 3 by 3. So 3 multiplied by 3, 2 3s, that's how that would work. 3 cubed is going to be 3 multiplied by 3 multiplied by 3. And so on and so forth. So 3 to the power of 5, we're basically going to take 3 and multiply it by itself until there are 5 3s. So 3 times 3 times 3 times 3 times 3 is going to be 3 raised to the power of 5. And then we can work that out, and that's going to give us an answer of 243, which is equivalent to 3 raised to the power of 5. So here I'm asked to write down a 6-digit number that has a 4 as its thousands digit, but I can only use the digit 4 once in this number. So for a question like this, I'd probably find it quite useful to draw out the spaces for the 6-digit number. So if we have 6 digits, I can draw out the spaces here. And I could put a comma after the first 3 working from the right, because sometimes we do that in numbers just so we can differentiate and easily see each lot of 3 digits. So now here it's going to be easiest for us to again work from the right hand side of this number and work our way up until we reach the thousands column, putting digits that aren't 4 in all of the other columns, and then when we find the thousands column, we're going to put the 4 in. So firstly, at the far right, this one here is simply going to represent the units, so the units at the end of the number. So I can just put a 1 in here, for example, and that's fine. Moving on up, if the number were to be 2 digits long, it's going to be in the tens, so this is going to be the tens column. And again, I can just put a 1 in here. And then one more, a 3-digit number, So the first digit of this is going to be in the hundreds column, which is not quite 1,000 in the thousands yet, so I can put a 1 in here as well. And then moving one further over to the left, now my number, if it were to have 4 digits, is going to be in the thousands. So this first digit of it is going to be the thousands digit. So that means that I can put the 4 in this column here. And this, if we were to leave the number as it is, we'd have 4,111. So 4 is going to be the number of thousands we have here. So we know that this is the thousands digit. So then moving on to the left even more, we've got the tens of thousands and the hundreds of thousands, which again we can fill in with any digit, making sure that these ones aren't going to be 0, otherwise this wouldn't actually, if the first number were to be a 0, this wouldn't actually be a 6-digit number because the first number isn't counting for anything. So there are lots and lots of different possibilities you can have for the answer to this, but as long as the 4 is the third digit, you will gain the mark for this question. So in this question, we're converting between different units. So, for example, in the first part, we're converting centimetres to millimetres. So here we're asked to change 35 centimetres into millimetres. Now, when we're moving from centimetres to millimetres, we're going to be multiplying by 10. Now, if you didn't automatically know this, we could take 1 centimetre, and 1 centimetre is going to be equal to 10 millimetres. So if I were to go from 1 centimetre to 10 millimetres, this is multiplying by 10, and that's just a quick way to remind me of how I'm going to convert between centimetres and millimetres. So if I have 35 centimetres and I multiply this by 10, that's going to give me 350 millimetres. So that's going to give me the mark here. So similarly here, I'm asked to change 7,700 millilitres to litres. So we're going from millilitres to litres, and this is going to be done by dividing our number by 1,000. Now we could work this out. If we have 1 litre of something, that's the same as having 1,000 millilitres. So if we want to go from 1 litre to 1,000 millimetres, we multiply by 1,000. And if we want to go from 1,000 millilitres back to 1 litre, we divide by 1,000. So in this case, I'm going to take my 7,700 and then divide this by 1,000 to get an answer in litres. So we're going to divide by 10, 100 and 1,000, and that's going to give us an answer of 7.7 litres to gain us the mark here. And now finally here, using the same sorts of ideas, I'm asked to change 0.32 kilograms into grams. So again, if I have a look at what I'm working with, if I take 1 kilogram for example, I know that that's going to be equal to 1,000 grams. So to get from kilograms to grams, I'm simply going to multiply by 1,000. And in this question, I'm changing 0.32 kilograms into grams, so I can take this 0.32 kilograms and multiply that by 1,000 to get an answer in grams. And that's going to take me to an answer of 320. So to get the mark here, I'm going to put in the answer of 320 grams. So here we're told that Margaret is thinking of a number. She says that her number is odd, it's a factor of 36, and it's a multiple of 3. And we're told that there are 2 possible numbers that she can be thinking of, and we're asked to write down these numbers. Now looking back to the criteria, if I'm going to start kind of listing some of the numbers that fit these criteria, I could list the odd numbers. However, there are quite a lot of them up to 36, which is kind of what I need to be working with here if the numbers are a factor of 36. Multiples of 3, again, there are quite a few of them, and I'm still going to have to list them up to 36. Or I could just simply start by working with the factors of 36 and then looking for these odd and multiples of 3 that are in this list, so that I'm not then looking through a list of odd numbers for factors of 36, which might prove a bit more complicated. So if I start by listing out the factors of 36, I can take 1 and 36 to begin with. Then 36 is divisible by 2, so 2 and 18. Then 3 and 12, 4 multiplied by 9 gives me 36. And then 36 isn't divisible by 5, but it is divisible by 6. It's 6 squared. And then once we've reached the point where both numbers are the same, or the first number becomes bigger than the second number, we know not to count that. So we can then stop here, because otherwise we're just going to repeat our factor pairs. So now that I have my list of factors of 36, I can simply go through them and cross out any even numbers, because we're told that the number is odd. So if I remove all of the even numbers from this list, I'm then left with only 1, 3 and 9. And the other criteria here is that the number is a multiple of 3. Both 3 and 9 are a multiple of 3, however 1 is not. So I'm left with the two possible numbers here that are odd, a factor of 36, and a multiple of 3, and we have the answers of 3 and 9. Now, as for how the marks were awarded here, you get the first mark for listing the factors of 36, or alternatively multiples of 3, or the odd numbers up to 36, but we must have at least 3 of these listed out in order to gain this first mark. The second mark is going to be for one correct answer, so either the 3 or the 9, and then the third and final mark is for getting both answers here correct. So here I'm told that Mohsin, Yusuf and Luke are going to play a game. At the end of the game, one of them will be in first place, one of them will be in second place, and then one of them will be in third place. And I'm asked to use the table below to list all of the possible outcomes of the game. So to just make this a bit more simple for myself, I'm going to basically assign them each a letter. So for Mohsin is M, Yusuf is Y, and Luke is L. And then I can just fill these into the table so that I don't have to write out the names. So we're basically looking for all of the different ways that these 3 letters can be arranged. So if I start with the one that I have above, so I've just made in order M, Y, L. Now in order to do this in a logical way, I'm going to basically switch around the last 2 before changing the first place one. So a different way of writing this, a different order here, if we keep the first place the same, keep that with an M, then change the next 2 around. So now we're going to go L in second place and Y in third place. Now that's all of the different options that we can have with M in first place, because there's only 2 different ways of switching the other 2 places around. So now again, I can take a different letter and put that in first place. So now Y is going to be in first place. And then M and L can be in any order in these 2. And then the similar sort of principle, if we keep Y in first place, the only other way that this can happen, which is different to the ones before, is if we switch L and M around and have them this way around instead. Now finally, if I switch to the third letter, so the L being in first place, I can then put these 2 other letters in any order, so M and then Y. And if I keep the L in first place again, I can switch the second and third place around, so Y and M. And that's all the possible outcomes with L in first place. So we've worked through this in a logical way with each letter in first place twice, switching the second and third place around, and that's given us 6 different options. Now if we have 3 different variables and we want to order them in as many ways as possible, the number of ways we can order them in is going to be 3 times 2 times 1, so 3 factorial. So that's going to give us 6 possible ways. And if I have a look, we have listed 6 possible ways here. There's 6 different ways of ordering these. So it's really important to have worked through this in a really logical and really focused way to ensure we don't miss out any options, don't repeat any options, and cover everything throughout this question. So we would have gotten the first mark here for getting at least 3 correct different combinations, and then the second mark is for a fully correct list but with no repeats or extras in the list. So here I'm told that Neil buys 30 pens, 30 pencils, 30 rulers and 30 pencil cases. I then have a price list which tells me the prices of each of these things. So pens you can buy 6 for 82 pence, pencils are 15 for 45 pence, rulers are 10 for £1.25 and then pencil cases are at 37 pence each. And we're asked to use this information to find the total amount of money that Neil spends on all of these items. So the way that I'm going to go about doing this is for finding the cost of each 30 of each thing and then adding them all together and finding the total cost for all of those. So if I start by working from the top of the list, pens, he wants 30 pens. Now if the pens come in lots of 6, how many lots of 6 are we going to need to buy to have 30 pens? So if I take 30 and then divide that by 6, that's going to give me 5 lots of pens. So I'm going to need to buy 5 lots of these pens in order to have enough pens. Now, 6 pens cost 82 pence, but it wants our answer in the form of pounds, so it's probably a good idea to just convert this here. So 82 pence is going to be 0.82 pounds. I'll just do the rest while I'm here, so 45 pence. Rulers are already in pounds, and then pencil cases, they can be converted as well. So if we're buying 5 lots of pens, I can take the 5 and multiply it by the cost of 1 lot of pens, which is 82 pence. And that gives me an answer here of £4.10 for 30 pens. Now I can add this to the value for pencils. So if I work with pencils now, if 15 are 45 pence, how many lots of 15 do I need to have 30? So I take 30, divide it by 15 and get 2 lots. So then I can take my 2 and multiply it by the cost for 15, which is 45 pence. And that's going to give me a value of 90 pence. Similarly here, I can move on to rulers. Now rulers are 10 for £1.25. So in order to buy 30, I'm going to need 3 lots of these rulers. So I take the 3 and multiply it by £1.25, and that's going to give me £3.75. And then finally here, I just have to work with pencil cases. Now pencil cases are 37 pence each, and if I want 30 of these, I just take my 30 and then multiply it by the cost for 1, which is 37 pence. And that gives me an answer of £11.10 here. So now I've worked out the cost for 30 of each of these items, I can simply add them all together and find the total, which is going to be the cost of all of the items. So £4.10 plus 90 pence plus £3.75 plus £11.10 is going to bring me to an answer of £19.85, which is going to be the correct total here. So now for how the marks were awarded here. The first mark would be for starting the process. So, for example, doing this 30 divided by 6 to gain an answer of 5 lots, that would gain me the first mark here. Then the second mark would be for using this, following it through and finding the cost of 30 pens, or pencils or rulers, either of these work. And then the third mark is going to be for using this process to find the cost of 2 of the 30 pens, pencils or rulers, so any 2 of these. So once I'd worked out the pencils, that got me the third mark. And the fourth mark is for adding at least 3 different costs together. So in this step here, we added all 4 costs together, but adding at least 3 would gain me a mark. And then finally, the fifth and final mark is going to be for the correct final answer here at the end. So in this question, I'm told that Emily drives 186 miles in 3 hours, and I'm asked to calculate her average speed for this journey. So if we're working with a distance, so 186 miles, a time, which is going to be the 3 hours here, and a speed, if I label these up, so distance as d, time as t, and speed as s, then I can kind of see the symbols for a formula emerging. So speed, distance, and time. Now, if I think back to the equations, I can remember that speed is going to be equal to distance over time. So for this drive, the average speed is going to be the total distance over the total time, which is what we have here. Now, if I take the distance, which is 186 miles, and I'm going to put the units on just so that I can be sure that this has been calculated correctly. And then I'm going to do that over the time, which is 3 hours. And 186 divided by 3 is going to give me an answer of 62. Now, if I look at the units given in the question, we have miles per hour, mph, which is miles per hour. And then if I look at the units in the division that I've done, we have miles divided by hours, so that's going to give us a unit of miles per hour here as well. So we know that we're working in the correct units, so I can just write down my answer of 62 to gain me both of the marks here. So now in this part of the question, we're told that Sarah drives at an average speed of 58 miles per hour, and this is for 4 hours. And this time we're going to be asked how many miles Sarah drives as opposed to her speed. So again, I can see that we're working here with the speed, so the speed is here, the time, which is 4 hours, and we're going to be working to calculate the distance. Now, if I know that the equation is speed is equal to distance over time, in order to get this in terms of distance here, if we multiply both sides of the equation by time, by t, we're going to be left with distance is equal to the speed multiplied by the time taken. So in this case, I can calculate the distance, so how many miles Sarah drives, by taking d is equal to the speed, which is 58 miles per hour, and I'll put the units in just to check, multiplied by the time, which is 4 hours, and 58 multiplied by 4 is going to give me an answer of 232. And then we have miles per hour multiplied by hours, so the per hour and hour are going to cancel out here and leave us with an answer which is going to be in miles. And as we can see, the units here for the question are miles, so I can write the 232 down to get both of the marks for this question. So here I'm asked to write down all of the prime numbers between 20 and 30. So if I'm looking for the prime numbers here, I'm just going to make this easier to visualise by writing out the numbers between 20 and 30 so that I can then cross off all of the ones that aren't prime and have other factors other than 1 in themselves. So the numbers between 20 and 30 go from 21 to 29. And initially here, I'm going to start by crossing off any that have obvious other factors apart from 1 in themselves. So I can take out all of the even numbers, for example, because they all have a factor of 2, so they cannot be prime. So 22, 4, 6 and 8, They're all even, so they have a factor of 2. Now similarly here, if we're working with numbers, consecutive numbers between 20 and 30, I know that there's going to be multiples of 3 within here. Now 21 is going to be 7 multiplied by 3, so I can cross this one off as it has a factor of 3 and a factor of 7, but either way we know that it's not prime. Similarly, counting up again, 24 is also a multiple of 3, but we've already crossed that off as a multiple of 2, so we know that that's not prime anyway. And going up again, 27 is also a multiple of 3, so we can cross that one off as well. Now looking at the numbers we have left, we have 23, 25 and 29. Now 25 is going to have a factor of 5, it ends in a 5, so I can cross that one out as well because it's got a factor of 5, so it isn't going to be prime. Now we're left with both 23 and 29, and both of these numbers are going to be prime as they have no other factors other than 1 and themselves, so I can write these down as the prime numbers here. So you may have instantly looked at this and seen that 23 and 29 are going to be the only primes. Sometimes you might be more familiar with the prime numbers, but if not, we can just look for factors and check as to whether these numbers have factors other than 1 of themselves, so they won't be prime. Now here we're told that Catherine says the number 2 is the only even prime number. And we're asked whether Catherine is right, and we must give a reason for our answer. So this question's just worth 1 mark, so we're just going to be looking to state whether she's right and then give a brief reason as to why we think this. So working with the number 2, firstly, number 2 is prime and it's even. And it's the smallest even number as well, just starting to think about this. And then if we look at the fact that it's the only even prime number. Now, a property of even numbers are all multiples of 2. That's their main property. Every even number is a multiple of 2. Now, if every other even number is going to be a multiple of 2, every even number is going to have 2 as a factor of it. Now, for a number to be prime, it must have only factors of 1 in itself. So if it's even, it must also have this factor of 2 and therefore cannot be prime. So in this instance, yes, Catherine is right, and that's going to be because all of the other even numbers, so all even numbers greater than 2, have the number 2 as a factor. So cannot be prime themselves. However, 2 has factors of 1 and 2, so 1 in itself, so therefore is prime. So in this question, I'm given an equation to solve. So I have here x plus x plus x is equal to 51. Now, I'm just going to start by making this a bit easier to work with. So we want to get it in kind of terms of x is equal to something. However, when we've got these 3 x's on the left-hand side, it looks a bit difficult to work with. However, if we have 3 x's, we can add them all together and get a total of 3x. And then 3x is going to be equal to 51. Now, if I'm going to find this in terms of singular x, in order to get 3x down to a singular x, I can divide this by 3, and that's going to give me x, which is going to be equal to, on this side, 51 divided by 3. And 51 divided by 3 is going to give me an answer of 17. So in this instance, x is going to be equal to 17, and I can write that in to gain the mark for this question. Now here we're given a question of a similar form. So I'm asked to solve y over 4 is equal to 3. So I want this in terms of y. So y is going to be equal to some number. Now, if we have y over 4 is equal to 3, we're dividing y by 4, and then that's equal to 3. So in order to get this answer in terms of just y, if we were to multiply both sides of this equation by 4, we're going to get an answer where y is equal to something. So y over 4 multiplied by 4 just leaves us with y. And y is going to be equal to 3 multiplied by 4, as we have to do the same thing to both sides of the equation. So 3 multiplied by 4 gives us an answer of 12. So in this instance, y is going to be equal to 12 to gain us the mark here. Now finally here, I'm asked to solve this equation. So 2f plus 7 is equal to 18 here. So again, I'm going to be trying to isolate f here. So to get f on its own side of this equals sign, and for it to be one lot of f as opposed to the 2 here. So to start with a question like this, I can see that I have a plus 7 on this side of the equation. Now if I'm looking to get f on its own, I really need to take this away and remove it from this left-hand side. So if I have plus 7, in order to get rid of that, I can subtract 7 from both sides of the equation. And that's going to give me 2f plus 7 minus 7, so that leaves me with just a 2f, is going to be equal to 18 minus 7, which gives me an answer of 11. So now I have the equation 2f is equal to 11. So I've got 2 lots of f here, and that's going to give me 11. So if I'm looking for one lot of f, I can simply divide both sides of the equation by 2. So 2f divided by 2 gives me f, and 11 divided by 2 is just going to give me 11 over 2. So f is going to be equal to 11 over 2, or 5.5, to get me the mark here. So here I'm told that a group of football fans were asked what their half-time snack was. And then we have the table below, which gives information about their answers. So the 3 options for snack were burger here, pie and hot dog. And then in the right-hand column, we have the number of fans that chose these as their favourite snack. So 11 for burger, 17 for pie and 8 for hot dog. And we're then asked to use this information to draw an accurate pie chart for all of this information here. Now, in order to draw this pie chart, we're going to have to work out what angle is going to represent each snack within the pie chart, and these are going to have to sum to 360 degrees because there's 360 degrees in a circle. So in order to work out the size of each angle, we need to work out how many fans, for example, choose burger in proportion to the other snacks. So how many choose burger out of the total number of people, and that's going to be the angle that represents those that choose burger. So if I start by working out the total number of fans here, we can take the 11, add on the 17 and the 8, and then we find that we have 36 fans in total. Now this is going to be quite useful because if we have 36 in total, it's going to be a number out of 36, and if we multiply this by 10 over 10, we're going to have a number over 360, which is the number of degrees in a circle. So the numerator of this fraction is going to be the number of degrees that is represented by this snack, so we can draw this angle in. So for example here, if I take the burgers first, and we have 11 burgers, people that choose burger, out of a possible 36 people. And now if I multiply this up by 10 over 10, which is just the same as multiplying it by 1, we're just scaling it up, we then have 110 over 360. So 110 over 360 is like 110 out of 360 degrees. So burger, this section of the pie chart, is going to be represented by an 110 degree angle. Similarly, pi, we can do the same again. So 17 this time over 36, because there's 17 fans that chose the pi. Multiply that by 10 over 10 gives us 170 over 360. So that's going to be an 170 degree angle. And then finally, for the hot dog, we have 8 people out of the 36. And we can times that by 10 over 10 to give 80 over 360. So this gives us an 80 degree angle. Now I can just check that these are going to work out. Now if I take the 110, add on the 170 and add on the 80, we're expecting this to sum to 360 degrees because it's going to be the complete circle. And it does in fact sum to 360 degrees. So we know that our angles work out here. Now all I have to do is use this information to draw up the pie chart. So I need to draw an 110 degree angle firstly for the burgers, and I need to make sure that I label up this angle and label up which section of the pie chart represents which snack as well. So I would be laying my protractor flat along this line here, and then measuring round and finding the 110 on the protractor, and then I would mark it up somewhere outside of the protractor like so, and then I'd connect the centre to this outside line and draw in the angle of 110 degrees, not forgetting to label up that this section is the burgers. Similarly, now for the pies, I would lay my protractor on this line with the sort of cross part here, and then I'd measure all the way round until I got to 170 degrees, or I could just measure this 10 degrees here from the other side. So then I would mark a little line where that was going to be, and then I could draw again from the centre out to this line here and mark this up as 170 degrees with pies. And then finally, I can just check that this last angle is going to be set 80 degrees because that's all that we have left. We're just going to fill in the hot dogs, so this angle should be 80 degrees. But it's always a good idea just to check this in case any of the previous ones have been drawn in slightly wrong. And then I can write hot dogs in here. And that brings me to the end of this question. So as for how the 3 marks are awarded here, you'd get the first mark for finding one of the angles, and the second mark for finding and calculating all 3 of the angles, or having one drawn accurately. And then the third mark is for this fully correct and labelled pie chart at the end. So here we're told that a scout group has a raffle to raise money for charity. We're told that there is 1 prize to be won in this raffle. We're then told that Laura buys 12 raffle tickets, and that a total of 350 raffle tickets were sold for this raffle. And then we're asked to use this information to find the probability that Laura does not win the prize. So initially here, I've got the number of tickets that Laura buys and the total number of tickets. So if I wanted to work out the probability that Laura did win the prize, then I could simply take this and take the number she buys out of the total number to find the probability that she has won the prize. However, we're looking for the probability that she does not win the prize. So in this sense, there are kind of 2 outcomes. She either wins the prize or she doesn't win the prize. There's no other set of events that could happen here. So the probability of her winning the prize plus the probability of her not winning the prize are going to sum to 1 because they cover all of the possible events. So if we want to find the probability that she does not win the prize, we can take this total of 1 and then subtract the probability that she does win the prize. To leave us with the kind of rest of the probability that she does not win the prize. So we can take this and we can basically take the 1 minus the probability that she wins the prize, which is going to be her 12 tickets out of a possible 350, and that takes us to an answer of the probability that she does not win, which is going to be 338 over a total of 350. And here we've calculated the probability that she will not win the prize by using the probability that she would win the prize and subtracting it from 1. So as for how the marks are awarded here, you basically get a mark for this initial calculation, so the 1 minus, and then you get the second mark for the final correct answer. We could have gone about this in a slightly different way and subtracted the 12 from the 350 at the start to get 338, and then we know that the probability of this happening would be 338 over 350. Either way, we come to the same conclusion here. So here we're told that each worker in a factory is either left-handed or right-handed. We're told that 22 of the 45 workers are male, and that 16 of the 34 right-handed workers are female. And we're asked to complete this frequency tree with all of this information and fill it all in. So firstly here, just to make sense of the diagram, we have the total number of people, so male plus female, all of these included, left-handed, right-handed, they're all going to sum to 45. And then this 45 is split off into 2 categories, so we have male and female here, which are going to sum to this total of 45. We can then take the male category and split them down into left-handed and right-handed members, and as you have to be either left or right-handed, then these 2 boxes here are going to sum to the total number of males. And similarly, the same is going to happen for the females at the bottom. So if I look back at the information I'm given, I can use this to fill in a couple of the gaps to begin with. So 22 of the 45 workers are male. Now this box here is for the total number of male workers, which we've just been told is 22. So I can fill that in initially here. Now, if 22 of the workers are male, and the male and female workers are going to sum to this total of 45 workers in total, we can work out the number of female workers by taking 45 and subtracting 22 to get the female workers, and that gives us an answer here of 23, which I can put into this box here. So now the total number of workers is 45, male plus female is equal to the total number of workers. Moving on, 16 of the 34 right-handed workers are female. So if we take female to begin with and go down to right-handed workers, we know that 16 of these, there are going to be 16 of these because there are 16 right-handed female workers. Now we're told here that there are 34 right-handed workers in total, 16 of which are female. So in order to work out the number of right-handed male workers, we take the 34 and minus this 16 to give us the right-handed male workers. And that gives us an answer here of 18. So I can substitute that into the right-handed male workers box. Now I just have 2 more boxes to fill in, and as I said before, the left-handed and right-handed are the only 2, a worker is either left-handed or right-handed, so these 2 must sum to the total number before, which is going to be the 22 male. So this box here is going to be the 22 minus the 18, which gives us 4. And similarly for the female, the left-handed workers, we're going to take the 23 minus the 16, as you have to be either left or right-handed, and that gives us an answer of 7 here. So now we've filled in all of the sections, And we can just check that each one, basically each pair, so these two branches sum to the branch before, these two branches sum to the branch before, and then we can check that we've got all of these correct and in the right places. Now, as for how the marks are awarded here, you get the first mark for basically placing one correct piece of data. So that could be either the 22 or the 16 that were given in the question. The second mark's for correctly placing a piece of data and for finding at least one unknown piece of data. So that would have been for the 23 here, or the 4, or the 18, or 7. And then the final mark is just for this fully correct, completed tree diagram. So in this question, I'm told that Mary needs to work out the size of angle X in this diagram. So we have the triangle here, triangle ABC, and we have angle X here. And then we have this angle, so ABC, the angle ABC, is 63 degrees. And then we're told that she writes X is equal to 63 because base angles of an isosceles triangle are equal. Mary is wrong, and we're asked to explain why she's wrong here. So this question is worth 1 mark, so we're just going to be looking to state a short reason as to why she is incorrect. Now if we look at this triangle, these little lines here show that these sides, AC and BC, are equal. So they're equal in length. So for an isosceles triangle, this is going to be an isosceles triangle because we have these two sides which are equal in length. And for an isosceles triangle, the reasoning here is correct. The base angles of an isosceles triangle are going to be equal. However here, angle X is not going to be equal to 63 because if we were to have a triangle like so, and these two lengths are equal, the base angles here are going to be these two angles. Now this triangle that we're working with is kind of rotated here. So in actual fact, the base angles of this triangle are going to be this angle and this angle here, which are going to both be equal and they're going to be 63 degrees. However, this angle here, the angle X, is kind of the top angle in this diagram. It's not one of the base angles because it's between the two sides that are of the same length. So angle ACB is not going to be equal to 63, so X doesn't equal 63, and that is because X is not a base angle. Alternatively here, we could have gotten the mark for working out what X would be. So if angles in a triangle sum to 180, we can subtract 63 and subtract 63 again, so both of the base angles, to leave us with X, which is going to be equal to 54 degrees, and we could have stated that to get the mark here. So now here we're told that William needs to work out the size of angle Y in this diagram. So we have the two parallel lines, so that's what these little arrows mean. DE is parallel to FH here, And then we have this line from E to G between the two parallel lines. And we have an angle of 57 here and an angle of Y here, which is what we're looking to find. We're told that William writes the following. So his workings that angle EGH, which is this angle here, so this angle here, is equal to 57. And the reasoning is because corresponding angles are equal here. And we then have the working that Y is equal to 180 minus 57 because angles on a straight line add up to 180. So they've taken this angle EGH and subtracted it from 180 to be left with Y. And we're told that one of William's reasons is wrong, and we're asked to write down the correct reasoning here. Now if we look at his reasons again, angles on a straight line do add up to 180, and this makes sense because if this whole angle here is 180, we subtract this part, we're going to get Y. However, the problem here lies with the fact that angle EGH is equal to 57 because corresponding angles are equal. Angle EGH is going to be equal to 57, but the word corresponding here is incorrect. So corresponding angles I remember as F angles. So for example, if we had two parallel lines, then corresponding angles would be this angle here and this angle here. They kind of make an F shape. Whereas the angle in question in the question, we're working with an angle like this, and it kind of makes a Z shape in this instance. So we're working across here, and we're making a Z shape. And the Z shape angles, I remember sometimes to do with A to Z, that kind of thing, A and Z being kind of next to each other, that the name for this is alternate angles. So to get the mark here, I'm simply going to write down that alternate angles are equal in this instance because we're working with alternate angles in the diagram. So here I'm told that Marla buys some bags of buttons. There are either 19, 20, 21 or 22 buttons in each bag. And we're given a table which gives us some information about the number of buttons in each bag. So in this column here, we have the number of buttons in each bag. So the bags with 19 buttons, 20, 21, etc. And then we have the frequency in the right-hand column. And this is the number of each type of bag that we have. So for example, there are 7 bags which have 20 buttons in. We're then told that the total number of buttons is 320, and we're asked to complete this table. Now here we're working with the total number of buttons. We're not working with the numbers or the frequency of bags. So in order to work out the total here, we need to look at the total frequency of buttons, the total number of buttons in these bags. So for example, if we have 7 bags with 20 buttons in, the total number of buttons here is going to be 7 multiplied by 20. And I can see this if I label the columns up. If we take this one to be X and then the frequency column to be F, if I then add on an FX column, this is going to be the total number of buttons looking at each bag individually. So, for example, if I take the second column, because it doesn't have an unknown in, I can simply do 20 multiplied by 7 to get me 140, which will go in this column. Similarly, 21 multiplied by 3, gives me an answer of 63. And then finally, 22 multiplied by 1, that just gives me 22. Now here, I'm missing this value in this column here because I don't have a frequency for the number of bags that have 19 buttons in. However, I do know that this f of x column, so the total number of buttons, is going to sum to 320. So if I take 320, subtract 140, subtract 63, subtract 22, then I'm going to be left with A, as all of these have to sum to 320. So in this instance, A is going to be 95. So there are 95 buttons basically represented in this row of the table. And if there are 19 buttons in each bag, we can take this 95 buttons and divide it by 19 in order to get the number of bags that have 19 buttons in, and that gives us an answer here of 5. 5 bags have 19 buttons in, and I can fill in the table with the answer of 5. Now, as for how the marks are awarded here, we get the first mark for starting the process, so basically working out the f of x column for 2 of the different rows. And then the second mark is going to be for completing the process to find the missing frequency. So when we kind of worked with this step here, dividing this by 19, that would gain us the second mark, and the third mark's for the final correct answer of 5. So in this question, I have a list of ingredients which are used for making 30 biscuits. So here we have 225 grams of butter, 110 grams of caster sugar, 275 grams of plain flour, and then 75 grams of chocolate chips. I'm then told that Lucas has the following ingredients. So he has 900 grams of butter, 1,000 grams of caster sugar, 1,000 of plain flour, and then 225 grams of chocolate chips. And I'm asked to use this information in order to work out what the greatest number of biscuits that Lucas can make is. So initially here, I'm thinking that if you can make a batch of 30 biscuits with these ingredients, we need to be looking how many batches we can make with the ingredients we have here. However, each separate ingredient is going to basically entail a different number of batches that we could make from it. So we need to look for the ingredient that is basically the limiting factor here, and the one that you could make the least amount of batches from, because we can't make more batches if there's not enough of one ingredient. So starting with the first ingredient here, if we work through them one by one, if we have 900 grams of butter, and you need 225 grams of butter to make 30 biscuits, if we take the 900 and divide it by the 225, then we're going to work out how many batches of these 30 biscuits we can make. And that's going to give us an answer of 4 batches. And we can just do the same for all of the ingredients in order to see which one is going to give us the lowest number, and that's going to be the number of batches that we can make. So similarly here, we take the 1,000, and then I'm going to divide that by the 110, which is required for one batch, and that gives me an answer of 9.09 to a couple of decimal places there. Similarly, 1,000 here divided by this 275 from the question, and this one is going to give me an answer of 3.6. And then finally, 225 divided by 75, and this time we get an answer of 3. Now if I look down these numbers of batches, the lowest number here we have is 3. So the chocolate chips are effectively the limiting factor here. They're the ingredient that stop us from making more batches with the ingredients that we have. So in this instance, if 3 is the lowest, then we can use this to work out the number of biscuits we can make. So if we can make 3 lots of what we're given in the question, which is 30 biscuits, we can do 3 multiplied by this 30 to get an answer of 90. And that is going to give us the correct number for the greatest number of biscuits that Lucas can make. So 90 biscuits is correct. So then here, if I look at how the marks are awarded for this question, the first mark is for a process to find the number of batches for at least 2 ingredients. So once I got to the caster sugar, that would have gained me the first mark for finding 2 of these. And then this mark could have been awarded for other things to start the process, for example, like a full method to find the maximum number of biscuits for one ingredient, or the amount required for one biscuit for at least 2 ingredients. There's a couple of different ways you could go about gaining this first mark, but just something to start off this process. The second mark's for a complete process to find the maximum number of biscuits after you've considered at least 3 of the ingredients. So getting to this stage where 3 multiplied by 30, that would give me the second mark. And then the final mark is for this correct answer of 90 biscuits at the end here. So here I'm asked to describe fully the single transformation that maps shape A onto shape B. And we're given the diagram here. So we have shape A over here in this quadrant, and we have shape B over on this side. Now we're looking for a single transformation that can take shape A to shape B in one go. So initially here, one of the first things that I've realised is that the slanted side of A here is on its right hand side, whereas on B it's on the left. So these two shapes aren't of the same kind of orientation here. In fact, B is going to be a mirror image of A, because in order to have these slanted edges on opposite sides, we could never do this with a simple translation. There has to be some kind of reflection that's happened here. Now, to get the reflection happening kind of vertically, so we have it going from this side to this side here, there's been a vertical flip as opposed to a horizontal one, otherwise we'd have some kind of shape below A, mapping it onto B, if it was flipped over the x-axis, say. So there's been some kind of reflection where there's been the line of reflection is a vertical line. Now, if we have a look at the points, so if we take the same point on A and B, for example, this point here, so the top point on these, we can see that they have the same y value of 4, so there's not been any kind of upwards or downwards movement here, it's just been horizontal. Now, if we look at the distance between them, we've got 6 squares. So there's been some kind of reflection that's taken 3 squares and then another 3 squares away from the original points. Now, because we take 6 and half 6, that gives us 3. So if we move halfway between these, we move 3 here, we're going to be touching the y-axis. Now, if we were to reflect shape A in this y-axis, we would be getting shape B here. For example, we can look at this point here. We reflect this point in the y-axis, so we go 3 to the left, and we're going to move another 3 over the other side of the y-axis, and then we get to this point here. So we can see that there has been a reflection, and it's been in the y-axis. Now this question is worth 2 marks, so we're going to have to state both of these points to gain the marks here. So reflection in the y-axis is going to gain us the marks. Here, 1 for the reflection and then the second for the y-axis, or when x is equal to 0. So working through this, looking at specific points on the shape and kind of the orientation and the way in which they've been transformed is a really good way to go about starting questions like this. So here we're told that a farmer has a field in the shape of a semicircle of diameter 50 metres. And then we can see the semicircle here, so the diameter is this 50 metres. And we're told that the farmer asks Jim to build a fence around the edge of the field. So this is going to be a fence around the perimeter of this shape. And Jim tells us how much it will cost. So the total cost is going to be £29.86 per metre of fence. But then we need to add on £180 for each day's work. And we're told that Jim takes 3 days total to build this fence, and we're asked to work out the total cost here. Now it's going to be very important we remember to add on this £180 for each day at the end of this question, and make sure we don't forget that important part of this question here. So starting here, if I'm looking to find the basically perimeter of this shape, if we want to put a fence around the edge of it, I need to find its perimeter. And we have the 50 here, however, we need to work out the distance around this curved edge. Now this is a semicircle, so it's basically half a circle. So its perimeter is going to be half of that, half of the circumference of the circle. So if I work out the circumference of the whole circle, I will use the formula, the circumference of a circle is pi d. So for the circumference, we have pi multiplied by the diameter, which in this case is going to be 50 metres, because in the diagram that we looked at a moment ago, we had the diameter of the circle labelled up as this 50 metres. So this gives us a circumference of 50 multiplied by pi, so 50 pi. However, we're working with the semicircle here, so we need to take this 50 pi and divide it by 2 to get 25 pi, which is going to be the length of this curved edge of the semicircle. Now that I've got this, I can add it onto this original 50 here, and then I'll have the total perimeter of the semicircle. So the perimeter is equal to 25 pi plus 50 metres. And then if I do this calculation, that's going to give me an answer of 128.54 metres rounded to 2 decimal places here. Now that I've got the perimeter, I can then work out the cost of this. So if it's £29.86 per metre of fence, in order to work out the cost of the fence, I can take the number of metres I have, so 128.54, and multiply this by the cost per 1 metre, which is £29.86. And that gives me an answer of £3,838.20 here. Now finally, I'm just needing to remember to add on the £180 for each day's work. We're told Jim takes 3 days to build the fence, so the cost for the work is going to be 3 days multiplied by the cost for each day, which is 180, so that's £540 total. Now the total cost is this price of the fence plus the day's work, so I can add these two values together, so £3,838.20 plus 540, add those together to get me a final answer here of £4,378.20. Now, making sure to work through this question in a logical way has really proved helpful here in making sure I don't miss out any of the key points. As for how the marks were awarded, we'd get the first mark for a process to find the circumference of the circle or semicircle, so here. Then a second mark would be for finding the perimeter of the field, so the whole perimeter of the field, like so. And the third mark will be for finding costs, so now finding the cost of the fence and the cost of the work. That gains me a third mark. And then a fourth mark is for adding the two costs that we've calculated together. And the fifth and final mark is just for this correct final answer, which could lie in between the range of £4,377 all the way up to £4,392, just depending on how you rounded your answer and how many decimal places the value of pi you used was to. So there's just a bit of a range here that allows for a few different values throughout this question. So in the first part of this question, I'm asked to simplify m to the 3 multiplied by m to the 4 here. So initially here, I've noticed that we're working with indices. We're working with two lots of m raised to different powers, and we're going to be multiplying them together. So if I'm thinking back to my laws of indices, and we're multiplying two different values together, I'm instantly thinking here of an example such as x to the a multiplied by x to the b. Now what we do here is we take the powers and we can add them together. So this would leave a result of x to the a plus b. Now this is a law of indices, so when we have two lots of m to different powers, we can simply add the powers together. So in this case we have, following the same principle, m to the power of 3 plus 4 gives us an answer of m to the power of 7, which I can put in here, as that's a fully simplified answer to this question. So now in this part of the question, we're asked to simplify this expression here. So 5 lots of np cubed, and then that whole bracket is going to be cubed. And we need to look at how we're going to simplify this. So in effect, this bracket that we have here is the same as writing out 5 multiplied by n multiplied by p cubed, and then that whole thing's going to be cubed. Sometimes it helps to look at it that way, just so we make sure that we know that we're not adding or subtracting any terms like this. So to cube this bracket, I basically have to cube each of the individual terms. So I'm going to raise each term to the power of 3. So if I start with the 5 here, I can raise the 5 to the power of 3. So 5 to the power of 3, and that's going to be multiplied by this n in the bracket raised to the power of 3. So multiplied by n to the power of 3, multiplied by, finally, p to the power of 3 to the power of 3 again. So p to the power of 3 to the power of 3. Now, similarly to the previous part of the question, I've got p to the power of 3. I'm raising it to the power of 3. This is going to require some knowledge of indices laws again. So if we have x to the power of a, and we're raising that to the power of b, this is going to give us an answer of x raised to the power of ab. So a multiplied by b is going to give us the power here. So in this case, when we have p to the 3 to the 3, we're going to do p to the power of 3 multiplied by 3 gives us p to the power of 9. So we have 5 to the power of 3 multiplied by n cubed multiplied by p to the power of 9. And we can rewrite that, so we have 5 cubed gives us 125. N cubed is as simplified as it can get. We can just write n cubed down. And then we finally have p to the power of 9. And these are all going to be multiplied together, so we can just write them together as one expression as 125 n cubed p to the power of 9. And that gains us both of the marks here. So the first mark would have been for 2 of the correct terms in this product, and then the second mark is for this fully correct answer. And then finally here, we're asked to simplify 32 lots of q to the 9 r to the 4, and that's all going to be over 4 lots of q cubed r. So we're working with a bit more of a complex expression here that we're looking to simplify. We have a quotient, so we have a fraction, so there's going to be some kind of division involved here. And just to make it a bit easier for us, I'm going to start by writing this fraction out in a bit of a nicer form. So the terms in the numerator and denominator, they're all multiplied together. So we have 32 multiplied by q to the 9 multiplied by r to the 4 here. So that's going to be useful to work with. I could rewrite this fraction. I could write it as 32 multiplied by q to the 9 multiplied by r to the 4 all over 4 multiplied by q to the 3r, so times r. And then, because we're multiplying all of the numerators and the denominators, the terms in each of those, we can simplify this again just so it's a bit easier to work with. So if I separate the numbers, so the integers here, we can take 32 over 4, and we can leave that as its own fraction. We can multiply this fraction by q to the 9 over q to the 3 to keep the q terms together, and then multiply that fraction by r to the 4 over r. Now this shows how we're going to work with the fraction. We didn't have to write it out like this to understand what we're going to do with the terms, but it is useful to kind of see how it looks and how we're working with it. So now I can simply take all of these fractions, simplify them, and multiply them back together. And I can start with 32 over 4. That just gives me an answer of 8. And then we're multiplying that by q to the 9 over q to the 3. So here, again, I'm going to be referring back to my laws of indices. So, for example, if I had x to the a over x to the b, so when we have the same sort of variable raised to two different powers, one over the other, this gives us an answer of x to the a minus b. So to find the new power, we subtract the denominator power from the numerator power. So here, working with the q's again, I can take q to the power of 9 minus 3 here. And then I need to multiply that by r to the power of, by the same principle, 4 minus 1. So we now have 8 multiplied by q to the power of 6 multiplied by r cubed. And because we're multiplying these together, we can just write them out next to each other. So the final answer here is 8q to the 6 r cubed. And we would get 1 mark for getting 2 of these terms right, and then the second mark for having the fully correct answer that we have here. So here I'm asked to find the lowest common multiple of both 40 and 56. Now, when I see the phrase lowest common multiple, I'm instantly thinking about using the prime factors of these numbers and how I can use these factors in order to find this lowest common multiple is kind of a skill that is taught and worked on at GCSE. I could simply list out a few multiples of both 40 and 56 and find the lowest one. However, this method makes sure that we've not missed any or done any of the calculations wrong, and we don't have to spend the time listing out these multiples. So if I take firstly the prime factors of each of the two numbers, so 40, I can split this into 2, which is prime, and 20, and again divisible by 2, and 10, and then 2 and 5 this time, and 5 is also prime. So those are my prime, that's the prime factorisation of 40. And I can do the same for 56. So again, I'll just start with 2 because it's easy to work with, and 56 divided by 2 is 28. Divide that by 2 again because it's even, gives me 14. And I can divide 14 by 2, and that will give me 7, and 7's also prime. So we have found the prime factors of 56 as well. Now to find the lowest common multiple of these, I'm going to put them into a Venn diagram. So if I take a Venn diagram and I have my two circles, and I'll label this one 40 and this one 56. Now I can put my prime factors in here. So as you can see, we've got 3 2's that are the prime factors of 40, and also 3 2's for 56. So these can go in the intersection of the Venn diagram, the points where they cross. I can put in the 3 2's. Similarly, I can now take the other factors, so 40 has a factor of 5 that hasn't been counted, however 56 does not, so that just goes in the region that's just the 40, and then similarly the 7 can go in here. So now to find the lowest common multiple from this, I can use these prime factors, taking into account the shared prime factors here, so the 3 2's, and multiply them all together to find the lowest common multiple. So we have 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 7. And this is going to give me the lowest common multiple because it's taken all of the prime factors into account but taken out any duplicates. So we've gotten rid of any of the prime factors that we've been sharing here. So this gives me an answer here, if we multiply these together, of 280. And we would have gotten the same answer if we'd have listed the multiples. However, it would have taken a little while to get to 280 when looking at multiples of 40 and 56. So we'd gain the first mark here for finding the prime factors of both numbers, or for listing at least 3 of the multiples, and then the second mark is for getting the correct final answer here. I'm now asked to write down the highest common factor of A and B, which we have above. Now this is similar to the previous part of the question, in the sense that I'm going to go with a kind of Venn diagram approach to this again. So looking for the highest common factor instead of the lowest common multiple this time, if I were to draw out a Venn diagram of A and B and their prime factorisation, the highest common factor is going to be whatever's in the intersection, so this region of the Venn diagram, multiplied together. And that's going to take the common prime factors, multiply them together to gain the highest common factor of both A and B. So in this sense, I could draw out the Venn diagram, or I could just look at which prime factors A and B have in common. So A has 2 to the power of 3, so that's basically the same as taking 2 multiplied by 2 multiplied by 2, multiplied by 3 multiplied by 5 is the prime factorisation of A. Similarly for B, we have 2 squared, so 2 multiplied by 2, that's multiplied by 3, multiplied by 5 squared, so 5 multiplied by 5. Now I just need to look between A and B and find these factors that are in common. So if we take 1, 2 from each one, and then we can also take another 2 from each one here, we can take the 3, that's common, and then we can take 1, 5. So there's lots of common factors here. However, we have this multiplied by 2 in A and the 5 in B, which aren't common, so we can just work with the ones that we've circled. So then the highest common factor is going to be 2 multiplied by 2 multiplied by 3 multiplied by 5. Here, multiplying the common factors together, and that gives us an answer of 60. And that is going to be the correct answer here to gain us the mark. So here we have the line L, which is shown on the grid, and we're asked to find an equation for this line L. So if I have a look at the grid, we have the x-axis here and the y-axis, and this is the line L, which is a diagonal straight line here. So if we're looking to find its equation, I always find it useful to basically write down the general form for an equation of a straight line, just so I can see clearly what I'm working with. So that is going to be y is equal to mx plus c. This is a general equation for a straight line. And if I have a look at this, basically we substitute in a value of x to obtain a value of y here. And we have m and c, which are fixed constants. So m in this case is going to be the gradient of this straight line graph. That's what this constant is going to be. And we can just substitute m in as whatever we calculate the gradient to be. And then we have this value. And then c here is going to be another constant, but this constant is going to be equal to the y-intercept of the graph. Now we can see this because when we have the y-intercept, the x value is going to be 0 when we're working with the y-axis. So this value here is going to be 0. If x is 0, mx is also 0. So y is equal to c. So the y-intercept is going to be this value of c. So I can then use this information to calculate and work out the equation of the graph. So if I start by working out the gradient, so m, we calculate the gradient by finding the change in y, so delta y, over the change in x for this straight line graph. Now I can do this by drawing out a triangle like so. So it can be any size, just going between 2 points on the line, and it's a right angle triangle like this. So now I can look for the change of y and the change in x. So if we start with x, we start with x is 0, and I'm going up here along this bottom line of the triangle, the horizontal line, to where x equals 2. So this is a change in x of 2, so 2 squares. And similarly for y, we start at -6, and we're going to go up 6 squares to 0, So there's a change of 6 squares. And then I can write this out, so the change in y is 6 over the change in x, which is 2, and that gives me an answer of 3 for the gradient. So if I substitute this back into the equation, we have y is equal to 3x plus some value of c. Now there's a couple of different ways we could work with this. We could substitute in a value of x and y that's on the line, so a coordinate, and we could work out the c by just rearranging that. Or we can simply look at the graph and find the y-intercept, so the c value here. So the y-intercept is when x is equal to 0 on this line here on the y-axis, where that meets the line L, which is here at -6. So c is going to be equal to -6. And then we can simply substitute that in to get our final answer. So y is equal to 3x, and we need to make sure we have this negative sign, -6. And that brings us to the correct final answer for the equation for this line. Now, as for how the marks are awarded here, we would get the first mark for basically working out this gradient that we did of 3. And then another mark for writing down this equation here. So just stating that we know that y is equal to 3x plus this value of c that we're then going to work out. And then the final mark was for this correct final answer here. There are a couple of different ways you can go about getting the marks. It just depends which order you've calculated things in and how you've used these values, and maybe you substituted in values to find c, or maybe you just read it off as the y-intercept. So here I'm told that Rhea buys a van for £8,500 plus VAT at 20%. I'm then told that Rhea pays a deposit for the van, and then she pays the rest of the cost in 12 equal payments of £531.25 each month. And we're asked to use all of this information to find the ratio of the deposit that Rhea pays to the total of the 12 equal payments. And we're asked to give the answer in its simplest form. So it's a lot of information to take in here, but if I go back to the start of the question, we're told that she buys a van for £8,500 plus this VAT at 20%. Now, if we're working with the total cost of the van, it's going to be a good place to start to work out this total cost, including the VAT. So if I go to work out this total cost of the van, I need to find what £8,500 is plus this 20% VAT. Now, if I have an extra 20% on top of this, I can take the multiplier of 1.2 to multiply this by 8,500 in order to work out what 8,500 is plus 20% of it. So 20% as a multiplier would be 0.2, but I'm multiplying it by 1.2 to have that original 8,500 included. So using this multiplier of 1.2, so increasing the value by 20%, I get an answer here of £10,200 for the van. So Rhea then pays a deposit for the van, but then she pays the rest of the cost in 12 equal payments. So we're not told the deposit here. However, we are told that there are 12 equal payments of £531.25 each month. So we can work out the total amount she's paid via these payments. So if we work out the total cost of her payments, well, if she is paying £531.25 every month for 12 months, so 12 equal payments, we can multiply that by 12 in order to work out how much she's paid. And that gives us an answer of 6,375. So that was the rest of the cost that she paid after paying the deposit. However, we don't know the deposit and we're looking to calculate the deposit. So in order to calculate the deposit that she put down to buy the van, we can take this total cost of the van and subtract the monthly payments in order to find the difference and to find the amount that she must have paid for the deposit, because the deposit plus the total number of payments, the total cost of these payments, is equal to the total cost of the van. So I can do the 10,200 subtract 6,375, and that gives me an answer of £3,825 for the deposit for this van. Now here, if I look, I'm asked to find the ratio of the deposit that she made to the total of the 12 equal payments, and we have both of these values here. So we're basically finding a ratio of the deposit to the 12 payments, and the deposit was 3,825, and we're going to put that in a ratio with the total cost of the payment, so this part of working here, so to the 6,375. And that gives us a ratio. This gives us the final ratio that we're working with. However, here we are asked to give our answer in its simplest form, so we're going to have to divide down this ratio. So these numbers are going to share a common factor, and one way of working out this is if I were to divide both of the sides of the ratio here by the same amount. If I were to divide them both by 3,825, for example, I'd get 3,825 divided by itself, so 1, and then I'd get 6,375 divided by 3,825, and that gives me an answer of 5/3. Now with ratios, it's better to work with whole number ratios, so I can simply multiply both sides of this ratio by 3, and that gives me a ratio simplified in its simplest whole number form of 3/5, and that will be the correct final answer here. So as for how the marks are awarded for this question, the first one would be for finding this total cost of the van, the second for finding the total cost of the payments, the third for finding the deposit, the fourth would then be for finding an unsimplified ratio, and then the fifth and final mark is for finding the simplified ratio of 3/5, or the answer 1/5/3 would have been accepted, but it's always a good idea to give them as whole numbers. So the way that we've laid this question out, giving a little more detail on what we're doing each stage of the working, writing down what we're calculating, has been really helpful in showing where we got all of the marks here and how it came together to give us this full answer of 3/5. So for the first part of this question, we're asked to complete the table of values for y is equal to x squared minus x minus 6. And if I have a look at the table, in the first row, so we have this row here, which is the row of x values, and these x values range from -3 up to +3. And then the second row of the table, we have y values. So we have some filled in, a couple filled in, then we're also missing some y values, so this is what we're going to be looking to calculate. So if I refer back to the equation we have here, in order to find a y value, we're going to take the corresponding x value, so the x value in the same column, so for example, this x value is linked to this y value here, and we can substitute it into this equation, which is a quadratic equation. So we would substitute in the values of x, so we would square the value, would minus the value of x, and then would minus 6, and that would give us an answer for y. So if I do an example of this, so if we take when x is equal to -2, for example, if y is equal to x squared minus x minus 6, and we're looking to calculate y, we square x, so -2 all squared, subtract another x, and then subtract 6, and that gives us an answer of 4 minus -2, so +2 minus 6, which gives us an answer here of 0. So I can fill that in to the corresponding y column that's linked to when x is -2. Similarly, I can do the same for -1. So -1 squared is 1, minus -1 is 1 plus 1, so 2. 2 minus 6 gives us an answer of -4 here. So I can fill that in also. We can move on here to when x is 1. 1 squared is 1, subtract 1 is 0, subtract 6 is -6. For 2, we have 2 squared, which is 4, subtract 2 gives us 2, subtract 6 gives us -4. And then finally, we have 3 squared, so 9, subtract 3 gives us 6, subtract 6 gives us 0. And we can kind of see a pattern emerging here as well. If we go from 0 to -4 to -6, and then back to -6 to -4 to 0. And we'd expect that kind of thing to happen somewhere in this graph because we are working with a quadratic, so a curve here. We're then asked to draw on the grid the graph of y equals x squared minus x minus 6 for values of x from -3 to 3. And then I have here the table that we've just worked out with the new values of y that we've put in. So effectively here, when we have the values of x and y, we've basically just formulated some coordinates that are points on this graph. So for example, if we have coordinates x, y, then points on this graph are going to include -3, 6, and then -2, 0, -1, -4, 0, -6, and so on. So we can just go through and plot these points on the graph, and then we can draw a line, a smooth curve through all of these points. Now, we know what we're expecting from this graph. We have an x squared term, so we're expecting a quadratic, and it's a positive, it has a positive coefficient, so a coefficient of 1 here means that it's going to be a kind of upwards curve, a smiley face instead of a negative one, which would be more of an N shape or a frown. We can also see that it's going to have a y-intercept of -6 here, so that's also something to look out for, and it's going to be a smooth curve because it's a quadratic. So we can just be checking for all of these things to check we're plotting our points correctly. So firstly here, if I start by plotting the first point, so -3, 6, I can plot that on the graph like so. Then -2, 0 is going to be at this point here. So I'm going to -2 on the x-axis, and then I'm going to 0 on the y-axis, which is just this point already. Similarly, -1, -4. So I take to -1 on the x-axis and then -4 on the y-axis to get the point here. We then have 0, -6. 1, -6 again, 2, -4, and 3, 0. Now I can see a curve emerging already, and now I just need to draw a smooth line through all of these points. I also need to make sure that this line is going to go below these 2 points here. As these are at the same height, there must be a turning point below them, so there must be a smooth curve between these two that goes below them. So now I can just draw this smooth curve in carefully. Just ensuring that I do go through all of the points there. Now, for how the marks are awarded here, you get the first mark for plotting at least 5 of these points correctly, and then the second mark is for a fully correct final graph here. Finally here, we're asked to use the graph to find estimates of the solutions to the equation, which is x squared minus x minus 6 is equal to -2. So if we're working with this graph of y equals x squared minus x minus 6, however, we're having this to be equal to -2, then we're going to be looking for the values on the graph where y is equal to -2. So this -2 is kind of in the place of where the y was. So if we're looking for where y is equal to -2, and we find the x values corresponding to the graph at these points, then we're going to have found the estimates of the solutions to the equation. So two x values here that are where the line y equals -2 cross the line y equals x squared minus x minus 6. So in order to go about doing this, I can simply draw in the line of y equals -2. So this straight horizontal line here, and label that y is equal to -2. Now if we look at where it intersects the curve, we have a point here and a point here. So it intersects the curve twice. And we would kind of expect that because it's said to find the estimates of the solutions, plural, and we're working with a quadratic here. So now I can look at these values and I'm trying to find the x values corresponding to these points. So if I trace up from these points up to the x-axis here, we can see we have one at -1.6, and similarly this point is at 2.6. So then my final answers here are -1.6 and 2.6, which are the solutions to this equation that we are given. Now, as for how the marks are awarded, you would get the first mark for drawing in this line of y is equal to -2, and then the second mark would be for getting the correct answers here, which can be in the range of -1.5 to -1.7, so 0.1 either side of the answers that I've given here. So here we're told that a force of 70 newtons acts on an area of 20 centimetres squared. We're told that the force is increased by 10 newtons, and then the area is also increased, and that's by 10 centimetres squared. We're told that Helen says that the pressure decreases by less than 20%, and we're asked whether Helen is correct, and told that we must show how we get to our answer. So the question is worth 3 marks, so it's going to take a bit of working before we can come to a conclusion on this question. We're also given the formula for pressure, so pressure is force divided by area, and we're going to need to work with that in this question. So if we're working out a way of looking at how the two pressures relate, whether it decreases by more or less than 20%, we need to work out the initial and the new pressure. So if I start by working out the initial pressure, so if pressure is equal to force divided by area, then we have the initial force, which is 70 newtons, and the initial area, which is 20 centimetres squared, and that gives us an answer of 3.5 newtons per centimetre squared, but because the units here are going to be the same, because we have centimetres squared in newtons and newtons in centimetres squared, just because we're doing this comparison, we don't really need to work with the units in this sense, because they're both going to be the same. So there we've worked out the initial pressure, and now we can work out the new pressure using the same sort of method. So if the force increased by 10, we have 70 plus 10 for the force here, and we're dividing that by the area, which is 20 plus the 10 as well. So here we have 80 over 30, and that gives us an answer of 2.6 reoccurring. So now we've got our two pressures, we need to look at a way of comparing them. So if we're looking to test whether the pressure is decreased by more or less than 20%, we could take the initial pressure and see where a 20% decrease would take us to. So if I take the 3.5 and I want to see what 20% less than that is, I can multiply it by 0.8, so find 80%, which is 100% minus that 20% of 3.5, and that gives me an answer of 2.8. So a 20% decrease from the 3.5 gives me an answer of 2.8. However, the new pressure is 2.6 reoccurring, or rounded to 2.7, and 2.8 is greater than 2.6 reoccurring. So we can conclude with this information that Helen is going to be incorrect, because the pressure has decreased by more than this 20%, because 2.6 recurring is lower, it's further away, it's much less than 3.5 than that 2.8% is. So no, Helen is incorrect. The decrease is more than, as opposed to less than, 20%. And that is the correct conclusion here for this question. As for how the marks are awarded, the first mark is for calculating the initial pressure or the new pressure, one or the other. And then the second mark is going to be for a more complete process to make this comparison. So this step here, multiplying it by 0.8 to find 80%. And then the final mark is for this correct conclusion, so working with these two values here, and then coming to this correct conclusion gains us the third mark, as long as we've supported the conclusion with these values. There are a couple of different ways you could go about this question. You could work it out by working with the new pressure. There's lots of different ways. You could work out the percentage change and see whether this is more or less than 20%, but any way should bring you to the same conclusion that we've gotten to here. So here we have a triangular prism, and we're given a diagram of this prism below, and we're asked to work out its volume, given our answer correct to 3 significant figures. Now if I have a look at the diagram, we have the front face of this prism, which is a triangle, so a right-angled triangle here. And then we have the kind of length or depth of the prism, which is this line, which is 18 centimetres. And if we're working with the volume of a prism, we simply need to find the area of the front face, so this triangle that we're working with, and we multiply that by the length of the prism. And that gives us the volume of the prism. So we take the area of this face here and multiply it by this 18 to get the volume of this prism. So to start this process, I'm going to work out the area of the triangle. However, the formula for the area of a triangle is a half multiplied by the base of the triangle multiplied by the height. However, we don't have a value for the base of the triangle. We don't know how long this side is, but we do know the height and the hypotenuse, so we can use these two values to work out the base using Pythagoras' formula. So if I'm to label up the sides A, B and C, for example, then we know that A squared plus B squared is going to be equal to C squared. And B here is the unknown. So if we want to find B, we can take away A squared from both sides, leaving us with B squared is equal to C squared minus A squared. And then I can substitute my values in. So if C is 8.4, I can take 8.4 squared, subtract A squared, which is 7.2 squared, and then that leaves us with an answer of B squared being equal to 18.72. And then to find B, I can just square root both sides. So B is equal to the square root of 18.72. And I'm just going to leave it in this form to work with for now, just to make sure that we're getting the right degree of accuracy and we aren't losing any decimal points here. So to carry on with this process, we've now found the missing side, B. And I now need to find the area of the triangular face. So the area of the triangle. And that's going to be equal to a half multiplied by the base multiplied by the height. So we can take that as a half and substitute in the two values. So the base is going to be side B, which is this root 18.72. And then the height of the triangle is side A, which is 7.2 centimetres. And for the area of the triangle, that gives us an answer of 15.57598, and there's more decimal places, but we've got a good few decimal places here to work with to know that we can give this accurately to three significant figures when we're working with the final answer. So now I have the area of the triangle, and to find the volume of the prism, I'm going to just take the area and multiply this by the length of the prism. So I can take the 15.57598, probably using the exact value here that I already have in my calculator, and I multiply this by the 18 centimetres, which is the length of the prism, and this is going to give me an answer of 280.368, and then many more decimal places. However, I now need to refer back to the question and see that it wants my answer correct to three significant figures. So three significant figures here. If I look at the first significant figure, we have the 2, then the 8, and then the 0 is the third. Because the 0 is in the centre of the number, it's not the first digit here, it's the third one, so that's going to be the third significant figure. So then I look to the fourth significant figure to see whether I round up or round down for the 0. And it's a 3, so 3 is less than 5, so I'm rounding down to the nearest number. So this takes us down to three significant figures to an answer of 280. To three significant figures. Because the 3 is less than 5, so we round down. The fourth significant figure is less than 5. So I can then write in the answer of 280 here to gain the final mark for this question. Now, as for how the marks are awarded here, the first mark is for starting a process to find this missing side. So this calculation here would have gained me a mark. I would get the second mark for finding the correct value for B, so the missing side here. Then the third mark would have been for a process to find the area of the triangular face, so this method here. The fourth mark was for finding the volume of the prism, so getting an answer here, which can be to more decimal places, obviously. And then the final mark is for the correct final answer of 280, correct to three significant figures here.